Finding the slope of a tangent line to a curve is an important problem in math. And as an example, let's say I want to know the slope. Now, parabolas don't have slope, but lines have slope, and tangent lines have slope. So I could ask the question, what's the slope of the line tangent to the parabola y equals x squared at the point 3, 9? And one way of getting an approximation for this approximate answer is to take a point on the parabola which is close to 3, 9, like 4, 16, and actually get the slope of this secant line. Secant hits the parabola twice. 16 minus 9 over 4 minus 3 is 7. And 7 is actually close to the real answer. But if you want a better answer, you can pick a point that's closer to 3, 9. For instance, 3.001, comma 3.001 squared, whatever that is. When you do the slope of that thing, 3.001 squared minus 9 over 3.001 minus 3, you end up with 6.001, which suggests that it's getting really close to 6. So the slope, and so we can infer that the slope at 3, 9 will actually equal 6. And it's true, it does equal 6. What about other points? Well, if you do the same process, but you use the point 5, 25, and do the same thing, where you pick a point really, really close to 5, 25, you'll find that the slope is going to get really, really close to 10. So when x equals 3, the slope was close to 6. When x equals 5, the slope is close to 10. It suggests that whatever x is, the slope's going to be double, at least for the parabola y equals x squared. And this is true. So if I want to know what's the slope at x equals 4, according to this, the slope is going to be 8. That's just for the parabola y equals x squared. What if there's some kind of coefficient in front of it? Well, the slope's going to be higher now, and it turns out that the slope in this case will be 6x, or you could even think of it as 3 times 2x. So it was 2x when there was no coefficient here. It's 3 times 2x when there is a coefficient here. So the slope at 4, 48, which is way up here, that slope, you can just plug the 4 in to this to become 16. In general, if it's y equals ax squared, the slope is going to be a times 2x. So if I say the slope, it's 5x squared at x equals 2, you can say it's 5 times 2x, which is 10x. That's what the slope's going to be. Then you could plug that 2 in to get 20. Now, if the exponent's not 2, like it's 3 or something like that, then it gets a little bit more complicated. The rule is you can multiply the exponent times the coefficient that's there, and then subtract 1 from the exponent. So, for example, 3x to the 5th power at x equals 2. The slope would be 15, that's 5 times 3, x to the 4th. At x equals 2, you plug 2 in, m equals 15 times 2 to the 4th, which is 15 times 16, which is about 240, which is a very steep slope. So to summarize, if the equation is ax to the n power, then the slope is na times x to the n minus 1 power. And then you just have to plug in the n, the a, and the x they would always say at x equals something. So that's the way you find the slope of a curve that's of the form ax to the n. You multiply the exponent times the coefficient, you lower the exponent by 1, and then you plug in the value for n, which is given to you, a is given to you, and then they also tell you what x is.